view of what you'll be seeing on the quiz tomorrow. So you'll get similar triangles. Okay, there are going to be two levels for similar triangles. The first level, like the level 3, the triangles are going to be oriented. The triangles are going to be oriented in the correct position, like this. Like the A and the D are corresponding, the B and the E are corresponding. Whereas the level 4, the triangles are going to be rotated or looking different. So the only trick is you have to figure out which angle corresponds to the other one. Okay? You're going to have to write a statement like this. Triangle ABC is similar to triangle DEF. You're going to have to solve for a side like this, where we set up the ratios and solve for it. Right? This might be what a level 4 question might look like. And then you will have a communication question like the ones we had in homework. I'm going to have you communicate. Now, when you're communicating, you're going to use words like similar triangles, corresponding angles, that kind of stuff. Okay, I'm trying to have you use proper math terminology. Next, you will have the second page is going to be all about sine and cosine and tangent. Okay, in the level 3 question, it will be more straightforward, like find this one side, find this one angle. Whereas for the level 4 question, I'm going to give you one triangle like I did just now. And I'm going to say, find all the missing sides. Okay. And you have to choose, are you going to use sine or cosine or tangent? Okay. So if you can do the second part of the lesson today, that would be a level 4 trig ratios question. Okay. Questions about the quiz. It won't take all lesson. I'll give you probably like 10 minutes to review and ask me questions. And then we will do part of the lesson tomorrow as well. Is it tomorrow that the quiz is? No, it's on Thursday. Sorry. On Thursday, I'll give you 10 minutes to study and ask me questions. Quiz. Okay. And so that means the quiz is on everything up to the end of today. So whatever I teach tomorrow is not on the quiz. Got it? All right. Let's look at this final ratio. So we're on page 8. And let's relabel this triangle because it's been a weekend. We're going to call this S. V. U. W. X. Y. Z. Now, to be really accurate, I want to show that these triangles are right angle triangles, right? So we want to put a box in the corner to say, hey, there's definitely a 90-degree angle on these triangles. Page 8, folks. Okay. Same triangle as before. I think the angle was 36. What do we know about this triangle? Well, let's get started. In the triangle SVU, we know that the bottom side, or if this is our triangle, if this is our angle, this is the adjacent. The adjacent is 4. The opposite is 3. And the hypotenuse, do you remember we calculated it as 5? For the blue triangle, the adjacent side was twice as long, was 8. The opposite side was 6. and the hypotenuse is 10. And then for the orange triangle, which is the longest, which is 3 times longer than the smallest, has all measurements that are 3 times greater. Right? So the connection to similar triangles is that these are 3 similar triangles, and they all share an angle of 36. So we've done 2 ratios thus far. Let's write them down. We have done sine is opposite over hypotenuse. We've done cos is opposite, is adjacent over hypotenuse. And there's one more that we have not done yet, and that is the tangent ratio. And so we just write tan as a short form. And so the tangent ratio is the only one that doesn't use the hypotenuse. So it's opposite over hypotenuse. Yeah, it is. I saw the confused looks and I'm like, I made a mistake. Thank you. Opposite over adjacent. Apologies. Okay, so before we actually put the numbers in, I want to introduce you to the acronym SOHCAHTOA. So what is SOHCAHTOA? Well, the SO is that sine is opposite over hypotenuse. The CA is that cosine is adjacent over hypotenuse. And the TOA is that tangent is opposite over adjacent. This is what makes it easier to memorize those equations. So let's look at this tangent situation. So if we're using tangent for angle S, that means we're looking at the OA, so opposite side over adjacent side. Okay, so for the blue triangle, we're going to have opposite is 6. Remember, opposite, it's not 6. Opposite is across from the angle that we're talking about. So if we're talking about angle S, the opposite one is across. So it's 3 over 4. So our smallest triangle is the green one. The second smallest one, the middle triangle, is the blue one. So opposite is 6 over 9, and I can reduce that fraction. No, it's not 6 over 9. 6 over 8, and I reduce the fraction by dividing it by 2, 3 over 4. And for the orange triangle, the opposite is 9, the adjacent is 12. And so if I reduce that fraction by dividing everything by 3, I get 3 over 4. And so what I see is that when I have the angle of 36 degrees, my tan ratio is always 3 over 4 or 0.75, right? Regardless of how big the triangle is. It doesn't matter how big it is. It's all about the size of the angle. So let's skip and write our findings about the tangent ratio. So tan of A is opposite over adjacent. And if we label this angle as our angle A, it's going to be opposite over adjacent. So if you're asked to find the hypotenuse, well, you're not using tan. Who thinks they are able to use tan now that you know how to use cosine sine? Yeah, we're basically doing the exact same thing. All right, so on your calculators, let's do just A and C. Let's find the tangent to the nearest thousandth. Okay, so tan of 40, tan of 73. This is really just to check that we're using our calculators correctly. And I get 0.8391. Check your rounding. Oh, this is interesting. What's interesting here is that for tan, I have a 3 point something. Whenever I did the sine and cosine, it's always 0 point blah, blah, blah. Here's a good communication question. So this is true. Sine and cosine ratios are always less than 1. Okay? In our acute triangles, and we're not talking about 90 degrees because I know that sine of 90 is 1. But in the right triangle, if I'm just looking at the acute angles, the ones that are smaller than 90, sine and cosine are always less than 1. I did not mention tangent. And I see, hey, I can have a tangent that is 3.273. How is that possible? Okay, so talk to your group. Why is sine and cosine always less than 1? And why is it that tangent can be bigger than 1? Look at the formulas. What's on top? What's on bottom? What's the longest side? Who's stuck? So, folks, which side is always the longest side? Hypotenuse. So, if I divide a smaller number by a bigger number, it's always going to be less than 1. Adjacent is always going to be smaller than hypotenuse, and so cosine is always going to be less than 1. So because sine and cosine have a denominator of the hypotenuse, that means that these two ratios will always have a value less than 1. Whereas opposite over adjacent, these are just two sides. Which one is bigger? Either one, right? Depending on the triangle. And so in the case of tangent, you can have a tan ratio that is bigger or smaller than 1. So let's see that. Yeah. So so in example 8, we're looking to find angle P and R. Okay, let's start with angle R. So how do I do this? Okay, so I'm looking for angle R. Now I'm going to show you how to use SOHCAHTOA as a tool. Based on this angle, now I just randomly said angle R. You could have said angle P, but I want to start with R. Based on angle R, can you please label all the sides? Which one is hypotenuse, which one is adjacent, and which one is hypotenuse? Which one is opposite, adjacent, hypotenuse? So you can even just use OAH. Okay, this is opposite. This is hypotenuse. And the last one is adjacent. Can you explain that again, Miss Sly? Anyone need me to explain it again? Yeah. So I said I'm going to start with R. So then everything, the O, A, and H are based on angle R. That means this is my opposite. That means this is hypotenuse. And this is right next to it. It's adjacent. Folks, what if I made this the angle I'm looking for? Would the hypotenuse change? No, hypotenuse is always the longest. Would the opposite change? Yeah, because look, now that is opposite. Okay, so the opposite and adjacent will change depending on which angle you're choosing. Okay, now the next step is how do I figure out if I'm using SOHCAHTOA or TOA? So I circle what I need to find, and I circle the two pieces of information that I have. I have the O and I have the A. If I have the O and the A, am I using SOHCAHTOA or TOA? Don't tell me. Tell the person you're sitting next to. Is it SOHCAHTOA or TOA? Good. Right? OA. So I'm using the TOA because tan is opposite and adjacent. Okay, so let's write my equation. Tan. Folks, what do I use for the angle? R. Okay. Now, if I want to find the angle, which button do I use? Is it tan or tan -1? Tan -1. Remember, for angles, we're always using, because we have to get rid of the tan and bring it to the other side. Okay, opposite is 8, adjacent is 5. And let's all get our calculator. Let's round to the nearest degree, so no decimals. Okay, and everyone is doing this just to make sure that you're properly using your calculator. You're checking if you use the correct, if you put the degree symbol. Anyone not get 58? Okay, now that I've done that, to find the other angle, I don't have to do any more work. I don't have to do any more trig work. I can just do the sum of angles. So angle P, well, angle P is going to be 180 minus the other angles. So minus 58. Do I have the other angle? Yeah, it's 90. In my head, I'm doing 90 minus 58, 40, 32. Right? As much as I can, I try to do the calculation stuff in my head just to keep my brain sharp. Any questions? There's a question out there. I know there is. What's the question? Alex, do you know the question? It's why did you do that, Miss Sly? What's the question? Why did you put that there, Miss Sly? In my last statement in my P box, what did you not do that I did? Amelia, give it a shot. What do you think the question would be? Perfect. Why did I put the dot above the equal sign? Okay, now this is advanced thinking, but I want to expose you to it. Why did I put a dot there? Did I round when I calculated P? No. Like in this 180 minus minus, I did not do any rounding. However, I'm using a number that has been rounded. 58 is not the exact value. That means that any new numbers I find cannot be exact because I'm using an approximate value. Put your hand up if that makes sense. Okay, so listen, I'm not going to penalize you on that. This is more like grade 11 work. I definitely want an approximate equal sign directly after rounding. But if you can remember, anytime you're calculating new values with approximate values, put an approximate equal sign there. Okay, that's just really good math communication. All right, let's try another question. Find the length of KL to the nearest meter given K equals 45. All right, so what that means is I know this is 45 degrees. I'm asked to find KL. I can also call it lowercase j. The first step I do is once I know what angle I'm using, then I label everything as OAH. Okay, so if this is my angle, that's going to mean this is opposite. Hypotenuse is always hypotenuse. And this is my adjacent. And now I circle the information I'm given and what I need to find. And I see that I've circled O and A. So I go back to my SOHCAHTOA. And I'm like, oh, I've got the OA, the TOA. So once again, I'm using tangent. Now in this case, I have the values for the angles. I'll write tan 45. What's opposite? Well, opposite is 10 centimeters. Adjacent is J. Solve for J any way you want, but I'll just remind you that you can use the T method by making sure you have two fractions. Draw the T so that it doesn't include the J. 1 times 10 divided by tan 45. So J equals 1 times 10 divided by tan 45 degrees. Everyone punch it in. Be surprised. Think to yourself, what does that mean? Did I make a mistake? Why would that be the answer? Right? We're going to use our critical thinking. Did we all get 10 centimeters? Is it exact or approximate? Yeah. Were there any decimals that you rounded? No. Now, does anyone know why it's 10 centimeters? Don't tell me, talk to your people. Why is Why are both sides 10 centimeters? Ooh, I heard it. Fill in the blanks. Both K and J are 10 centimeters because triangle KJL is a what triangle? I heard it. I heard someone say it. An isosceles. So two sides and two angles are identical. So that would be a good communication question. Why is tan of 45 equal to 1? All right. So as you do this homework, you might want to skip through the tan homework. Emily, turn around. You might want to skip through the tan homework if you feel really comfortable with it. And also because 6.6, what we're going to do now, you'll do tan, right? What we're going to do in this next section, we're skipping question 10. Sorry, we're skipping page 10 and 11. And we're going to page 12. So in section 6.6, the only difference is that now you're going to have to find all the missing pieces like you did in the warm-up. And I'm not going to tell you whether you do sine, cos, or tangent like you did in the warm-up. So when you are asked to solve a triangle, it means determine the lengths and angles of all sides, all missing lengths and angles. So let's try one out. This is triangle ABC. We are not told which one is the longest side, so let's just call it A. Let's make B the hypotenuse. And see here. Let's use good form and draw in the 90-degree angle. And so show me with your fingers, how many pieces of information are we given about this triangle? Good. Lovely. I see that we have 3 pieces, 90 degrees and 2 sides. Okay, so we can't start with C because we don't have any angles. So let's start with finding the angles. And I'll just randomly choose A. Okay, let's find angle A. So if I'm starting with angle A, then let's label the triangle based on angle A. So this is my hypotenuse. For angle A, that's my opposite, and that's my adjacent. Circle the information you're given. Circle what you need to find. Well, I need to find this. And so if I have the O and the H, okay, I gotta write this again. SOHCAHTOA. Which one has the OH? So that means I'm using sine. So I just use SOHCAHTOA to tell me which ratio I should be using. Okay, so if I'm using sine of angle A, I've got opposite over adjacent. So the opposite is 11. The adjacent is 13. Now, since I want to find the angle, I'm going to use the sine inverse button. So as I move the sine to the other side, because I'm undoing it, I have to use the sine inverse. Okay, so I've got sine inverse, right? You go shift, and then in brackets, you're going to go 11 divided by 13, close the bracket. How do I round? Find the side lengths to the nearest tenth and the angles to the nearest degree. Okay, and that means my angle A is 58. Because we're finding 3 pieces here, I'll put a box around anything I find. Next, let's find angle C. As soon as we have 2 of the angles, we can use the sum of angle theorem. And so the sum of angle theorem says that angle C is 180 degrees minus the other 2 angles, minus 90, minus 58. Excellent. I love that people are punching it into their calculator. You're being active. This is good. And we get 32. And if I'm a real math pro, what type of equal sign am I using? Approximate or exact? Who's not sure? Who's just quiet? Put your hand up. Am I using approximate or exact? Good. It is approximate because we rounded the 58. We're using an approximate value. Okay, so as I'm solving, I need to find all the information. I have 2 angles. The only thing I don't know is this side C. So step 3 is going to find lowercase c, or if you like to call it BC. No, not BC, BA. When I'm finding this side, I can use either of the angles. I'm going to stick with angle A because I've already labeled it for angle A. Right? So for this question, I'm using angle A. I am finding this adjacent side. I'm going to call it adjacent because it looks confusing. Right? It's a lowercase c. And now, do I use the H or the O? Or does it matter? So it doesn't.
Please excuse this interruption. Just a reminder to the grads, there's an OSAP workshop today in room 111, Ontario Student Assistance Plan. Information on getting loans and grants and bursaries.
If I
see you in room
use
111.
So if I said I'm going to use 11, that's O and adjacent. So that would be TOA. If I use H and adjacent, that would be cos. Now let's stick to today's lesson and let's use OA. So we're going to have that tan. What's the angle I'm using? I'm using 58 equals opposite over adjacent. For adjacent, I'm going to write lowercase c. over 1. And I'll have that C equals, okay, I have to do T method, 1 times 11 divided by tan 58. So 11 divided by, and I'm going to round to 1 decimal place, 6.9 centimeters, and it is approximate. So when we say to solve a triangle, we're really just saying find all the angles and all the sides of the triangle. We didn't get to example 2, nor the, we didn't do that word problem. All right, we'll look at that tomorrow. But for now, yeah, try the homework. If you can't do the word problems, that's okay, but give them a shot. And if you don't have that much time for homework, focus on section 6.6 as opposed to the tangent section.